Okay, so who needs rehearsals? So this one I haven't practiced, so hopefully everything goes according to plan, but what I'm going to do is I'm going to show you a method that I use to generate some quick haulage in Spry. I've generated a bit of a toy model for this exercise because it demonstrates a little bit better than the regular demo model does. But pretty much what we've got here is a real basic toy that builds up over time. It has a few benches. It's something that's you could envision like there being a mid-pit road, and then there's a few different roads that might be running along the sides of the pits. So what I'm going to show you is how to get some semi-realistic starting haulage numbers for this using vectors and a couple of roads. And so what we're going to do, what we're going to start with is we're going to generate the roads that head along the middle of this pit. So I'm going to define that the roads sit at this 120 RL for this particular exercise. So let's go our roads there, get a design, we'll create our shape. We've got the nice little smart snap now, and it's just literally going to run because my road is nice and simple. I tried doing something a little bit more complicated and I couldn't work out how to do it without a design package, so I just decided to do it like this. So we've just got these nice two roads that are running down the sides of our pits, and I'm going to make these universally attachable and detachable. I don't really care where they're going from and going to. When we're going to use more specific vector logic to make sure that they are attachable and detachable. I don't know why I did them separately. So anyway, so we've got these two. We'll thicken them up so they're a little easier to see. We've got these two nice shapes running down the sides of the pit. I thought I thickened that one up. I must not have. Alright. So got these two nice attachable, detachable shapes running down the sides of the pit. And so what I want to do now is I'm going to go, this is where the meat of this particular tutorial is going to head over to my vector logic. So I've created a rule. I just wanted to make sure before I got into this that I actually could generate, that my schedule was set up properly for haulage. But what we're going to do here is I'm not going to turn it into an attach or detach rule yet. It'll just make it a little bit easier to show you the preview of what's actually going on. And I've just realized that I thought I was fully set up, but I need a centroid for each side. So just bear with me half a moment. It's probably going to take me about 45 seconds to set this up, so if you're watching this video and it's not live, sort of skip forward about 45 seconds and you should be right. Utilities, centroid calculator, solid to, we're at the destination, so we'll go roof, fire that one off. That should be nice and quick. And the other side. Sorry about this. As I said, there's been no rehearsal of this because I've done this a bunch of times. So centroid calculator again. Once again, we're on the source side this time, so we'll go with floor. So in this toy, everything's cut at 5 meter benches. It's 50 by 50. There's something like, I don't know, 120,000 records or something in the table. I can't remember. And the final thing we have to do is link it to our processes. So we'll go across here and link our centroid field on the process and link our centroid field on the destination. Okay, setup out of the way. So what I'm going to do is this whole system works on a two-tiered system. We're going to do a little bit of working out in a group, and this is not going to get added to the profile at all. And this is just something for us to ascertain how deep we sit in the pit. Now in this example, in this model, you can see there's a nice reasonably consistent angle on the dig wall over time. It varies a little bit, but for the most part it's pretty consistent, and this is one of the things that this system relies upon, is some reasonably consistent dig and dump angle. If your dump angles are varying wildly and your dig angles are varying wildly, this might not quite work for you. So I'm going to set right back to the start, and what I'm going to do is I'm going to measure the, I'm going to use the angle of the face to determine how far up the pit I need to go. This is one of those things that may become clearer once I've finished the video or once I've finished the process. But we're going to start with the process centroid field. We're going to call this centroid. We're going to start there, little orange dot, and what we're going to do from here is we're going to add a vector that looks up the face, and it's going to be roughly whatever the dig angle's at. So it's, we'll just go with, I think it's straight up at 0, and then we're going to measure the grade, and the grade is approximately, I'm not going to use perfect numbers here, let's just go with 60%. And what we're going to intersect with in this particular example is the RL of the road. So we're going to keep going up to the RL of the road, so the Z level of the road. And so what you'll see is we have this particular vector now has found its way up to this point, and then what I want to do is I then want to seek out this road over here. So we're going to do one road at a time. This road can be call this road 1 mid-pit touch. I'm just going to call it road 1 for simplicity's sake, and this one's going to say what direction are we going for this one? This is a vector. It's going to look, which direction is this? Sorry, east. Okay, so this one, look up the face for road RL, and this one says look east to road 1. So what we're going to do here is we're going to look up the face at 90 degrees, and we're going to look for now the polyline that is the road. So I've now started at the centroid, I've looked up, and I'm looking across for the road here. And what you'll find, I need to do one more thing here, but I'll explain it in a second. But what you'll find is no matter where I sit in the pit, for the most part, I'll skip forward to like several strips into the future. Let's go all the way down to, let's say, this one over here. Is what you'll find is no matter where I am in the pit, I'm always looking up the face at the dig face angle and then looking in the direction of the road for the road network shape, and I'm finding it every time. Now what I haven't accounted for at the moment is attaching or getting to this road from the other direction. Now there's a couple of different ways to do this. I'm going to show you a slightly different way to what I would normally do, just to give you a different look. And this is going to be, we're going to call this one the working out group. But then we're going to add a conditional group here. So we're going to go working out above, and we'll call this one working out below road. And so one of the things that we can do with groups now is we can set their condition to be above or below a certain Z level. So I can say if your process centroid is above or below, in this example, is below the 120, then you're going to be looking up the face towards the road. And then what I can do with the alternate condition is I can say if you are above the one, I'm going to say 119, because what I want to make sure is I collect the 120 at some point as well. And we'll go if the process centroid is above the 119. And so I'm going to have some shapes in green here that are above the road, below the road, sorry, and then on the opposite side, I'll just do a quick lazy copy paste. I probably should have copy and pasted the group, but we'll grab this one as well, copy, paste. Now, what we do with this step when we're above the road is we don't look up the face. What we do is we look, I don't know what's happening with that right click menu. I think it's, oh actually I've got a bad mouse at home. We're going to look down the face at the opposite angle. So this one looks up the face 0 degrees at 60%. This one's going to look down at 60% at 180, and it's going to look for the same RL. So we're either going to look up the face, or when we're above, we're going to look down the face. But the second part of it is still the same. So no matter where we are still going to be looking back across the face to the road network. So if we look at, say, where's this one? Centroid. Okay, that's an interesting artifact of having never practiced this process before. I just don't like these grey lines. I'm going to make a slight adjustment to this because regardless of which group we use, we always need the centroid. So what I'm going to do is I'm going to put the centroid up into the top part of this group regardless, and so we'll get rid of that one as well. Just a bit of an odd artifact, and if you guys are going to end up copying pasting this, I want it to be something that looks a little neater. So that one there. This grey line that's cutting across here, that's tricking me a little bit, this is called the source destination line. So that's where the destination is for this particular record. Okay, so to summarize, we've started at the centroid. If we are below the road, as we are in this example, we look up the face at the dig angle of 60%, and then we look across to the road at the angle that the road is at. If we are above that road, then we look down the face. If we are above the road, we look down the face towards the road, and then we come back across. And so the whole point of this is that regardless of where we are in the pit, I'll skip forward random amounts of time, pick a random point anywhere in the schedule, is what we are finding is no matter where we are, we have the ramp point. So that is sort of step one of this entire process, is how do we find that ramp point no matter where we are. If we're up high, down low, we're trying to reach this mid-pit bridge. This is step one of this process is now complete. All of the working out parts have been done, and when I say working out, I mean stuff that's not driven to. So the next part of it is driving. So I'm going to create driving group where we're above the road. In fact, what I'm going to do, so I'm a little bit lazy, so I'm going to take that group, I'm going to paste it, and clear that out. It's just I wanted that condition of if I'm above the road. So this one's going to be called driving above the road. So I'll pick one where I'm above the road. It's also helpful to pick one that's like particularly high up, so I'll pick one up that's quite high. Let's go with like the 210, that's reasonably high. Okay, so in this example where I am so far is I'm down here. Okay, so this is my point where I've reached the maths. So the first thing I'm going to do for the driving part is I'm going to switch the group direction to reverse. And what this means is I'm going to drive, I'm going to draw my points back from the road towards the excavator, but when I drive in the profile, I'm driving from the excavator back towards the road. If you're not sure, this is the kind of stuff that is sort of introductory vector haulage stuff, but if you're going to be copying and pasting, it shouldn't be a problem. Okay, so we're going to take that step, we're going to add it, and this is going to be the ramp point from working out. And what we can do is, even if we're below the road, we can pick this point here. The last thing in the working out group is going to be the thing that we use. So we're going to use previous step and then go this one here. Even if we're below the road, this point is always going to be, we're either going to hit this point or we're going to hit that point. Also, the look east to road actually is external to the condition, so probably what I'll do to make it really drive the point home with a sledgehammer is this is working out. This was more just to demonstrate some functionality that you may not have seen before. Okay, so if we're above, we do that way. If we're below, we look that way. But both times we look east to the road. Okay, so we're looking east to the road, and that's where we're starting. So we're going to drive to this point, so we're going to add it to the profile. This is the first time we've actually added a point to the profile in this system. Then what I'm going to do is I'm going to start ramping up. So I'm going to take that, I'm going to launch off from that ramp point, and I'm going to ramp up at whatever angle it is that I like here. And I'm going to ramp up to the Z level of my process centroid, but I'm going to add a condition to it. So I'm going to go up at, let's say, 10%. Now you can see in this particular example that is a very, very, very long ramp. Okay, so what I'm going to do is I'm going to introduce a switchback, and I'm going to introduce several switchbacks. I might loosen up that angle a little bit so that I can actually fit a switchback or two in here. So this is going to be called ramp up 1. And pretty much from here, I'm just going to add ramps. I'm going to copy them, and then I'm going to switch them back. So I'm going to point it back up this way. And actually, the thing that I missed This is, as I said, I didn't do a rehearsal. The thing that I missed here is this should have a distance limit on it. So let's just put in a distance limit of, let's say, I don't know, 500 meters, maybe even to drive home how this is going to work. We might go 300. So we'll go with a 300 meter maximum length, and then I start inserting copies, but changing the bearing, and that's all I have to do. So I insert a copy, change the bearing, insert a copy again, change the bearing, and one more for good measure. And this one I won't limit. So the bottom one I won't limit, just in case for some reason 1200 meters is not enough ramping. But the final thing that I need to do in all of this then is add the drive to the actual centroid. So call this one source, but same thing. So what I do is I'm driving from in reverse back from the source back towards the road. And if we turn off the solids for a moment, what we're going to find is no matter where we are, oh sorry, this one is a driving above the road. We haven't done the below the road, so let's copy that, paste that in as well. This one will be below 120. Okay, and from here we pretty much just need to do the whole process but in reverse. So whereas before what I did was I said you go up at 10%, we'll change everything to go down at 10%, and all of the bearings of those ramps, instead of going sort of to the left here, I'm going to angle them off this way. Switchback will go that way, back this way, and then back this way, that way. So once you've done this a handful of times, you'll get the hang of it. These are all ramped down. And also, like, I'm creating this from scratch, but the whole purpose of a system like this, and me providing you with a copy of the model in the description of the video, is so that you can take this and you can copy paste it. I don't generally actually do all this from scratch, unless if I've got a model handy, I'll just copy and paste it. Obviously, for me, I've done it so many times, I can do it up quite quickly, but you can take this, you can copy paste it, and this is a reasonably universal rule that you just take the variables and you change them. So you take where the road is, you take the polyline, so you take this polyline, you'll change the polyline, you'll change the ramp angles, you change the grade angles, but the actual logic itself is kind of reasonably consistent. So we've got the ramp down system, we've got the ramp up system, and no matter where we are in the pit now, we have an option that will find this mid-pit road. Okay, so the last thing that we do is we'd set it to attach, but before I do that, I just want to hide the solids for a moment. Actually, what I might do is set the solids to be transparent so you can still see them as they progress. And what we'll do, the lines are a little bit distracting, but what we'll do is we'll just flick through it over time, and you'll see that the higher we are, the more switchbacks we get, and then when we're lower, we get deep switchbacks. You can see the switchback angle is a little bit too tight, so sorry, a little bit too loose, so we probably need to go ahead and grab this ramp and maybe angle it in a little bit more tightly so that we don't overshoot our source centroid. Pull that up a little bit. Looks a little bit nicer. But what we're getting is, we're getting a series of 10% ramps, we're getting switchbacks which have speed limits on them, we have corners which have limits on them, so we have a reasonably close distance, a correct representation of the slowdown involved with switching around, turning around. So even though the location of the road is not necessarily perfect, it's a close approximation to the amount of effort required to get to this particular road from any location. So I can pick any location that I want, and I'm going to get that varying ramping system. So if I'm low, I get, anyway, I'm repeating myself. So you'll see the point is wiggling a little bit, but this doesn't play any real role on like your cycle times. We're wiggling at 10 or 20, 30 meters at a time. Visually, it can look a little bit funny, so there are ways to get it. There are ways to do more complicated versions of this, but as I said, this is nice and quick for me. So I'm going to take this, I'm going to set it to attach. And it's going to complain there's no way to detach, and that's fine, because what I'm going to do now is show you the power in this system, which is once you've gone through the effort of generating this, the copying and pasting component makes things really, really simple. So I'm going to take it, I'm going to insert a copy, and this one's going to be called road 1 mid-pit detach. I'm going to change it to a detach type, and I'm going to go through references to the centroid, and I'm going to change it to be destination centroid. What I should have done with a handful of these other records, like this one here, the source, I should have actually made it reference a previous step, so that I only have to change the reference to the centroid once. That's just because I haven't rehearsed this and done it properly, so that should be previous step centroid, and I'll change these ones as well so that when I provide the copy, it's better. So this just means that when I need to change certain elements of this, I only need to change them once. I don't need to remember to change them, you know, half a dozen times, zipping through and making lots and lots of changes. I mean, there are still some, you still need to go through this and change them, but so I've changed the centroid now. Just make sure that I've renamed this one to centroid. Yep. Okay, so that's been now linked to the destination centroid. Okay, so now we just need to start toying around with the look up the face, look down the face side of things. So in this example here, I'm looking the wrong way. So all of my centroid stuff, all my look up the face, down the face is looking the wrong way. So now I just need to flip everything around. So if I take this, flip it around, take this, flip it around, take this, that actually the angle for the finding of the road will still be the same. So this one here should be looking Z level. My groups are using the process centroid field. That's the other thing you need to go through. I haven't actually done this process before using the grouping. I'm not sure that I actually would necessarily do it this way myself. Okay, so there we go. Alright, so above the road, below the road. Okay. So we have a handful of records where things don't work, but I don't want to focus on the outliers in a system like this. I want to focus on the things that are working for the vast majority of these. So let's have a look and see what's happening on the dump side. Sometimes what I like to do to test what's happening with stuff to try and make sure that I'm on the right page is I'll flick through things and set them from attach or detach back to none. It's just I can look at it without the necessarily like the visual confusion of seeing everything else playing out. So this one should be looking down the face. It should be called look down face. It should be looking this way, which I think it already is. Yep. And it is going, okay, so it is going down the face. Oh, it's now my ramp angles. Yep. So my ramp ups are going to the left, so they should be coming up this way here. So I just need to toy around with, if I'm going to switch back, then I'm switching that way. And then so this angle, just copy paste, copy paste. They're ever so slightly different, but it's a subtle enough difference to make them look strange. Okay, so let's just test all of those. Looking pretty good. They're overshooting a little bit, but that's because the early phases can't actually find a road for it to work on. That's okay. I don't want to get caught up in the troubleshooting element of this. So I want to look at the other side of it. So let's look at records that are above, and let's fix those ramp angles as well. So if we are, if we're below the road, we should be ramping down. So we'll just switch back that way, and do a bit of copy pasting. Okay, so where's a good example? Destination centroid. Ramping down. Oh, and I'm intersecting with, of course, the wrong thing. So these should all be intersecting with, that's the other part of it that I missed. So once again, the copy of this that you get will have had these mistakes that I've made while I'm trying to explain what I'm doing at the same time. So I need to change all these references in the dump side to reference this one centroid change. So centroid, 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 centroid. I will end up creating a version of this video that is a little more polished. Apologies, it's trying to find the time to get into detail like this is a little tricky at the moment, but we will get there. But for those of you who are interested, this system, once you've got your handle on it, will save you a bunch of time. If I'm not explaining myself and trying to make it more universal, I'm already done. So just changed all those references to centroids, change this back to attach, and I'm pretty sure, detach, sorry, I'm pretty sure I am done. And this is really what I wanted to get to in terms of the showing off of how the system actually behaves. We're not quite there with this one. Point from below. It's just it's this little bit of the road here. It's on the dump side. It doesn't quite extend far enough. Easiest solution in the polyline is actually to add my own points to the polyline. So I'm just going to add another little point to the polyline here, and you'll see I find myself at the road because I didn't draw it actually at the right RL. I need to change that RL to the 120. You would have your roads drawn in properly, would be my suggestion. And then back to the attach. So this one's detach type, and I just want to touch the logic up a tiny little bit. So the logic here should be really tight. So you should be finding the road network like with the actual logic that you're drawing. Okay, so after all of that, the point of all of this was to show you what we can get to with the amount of effort. So I might put a skip time in the video up to this point, so if all you want to do is see what the actual purpose of me going on through this is about, is so you can pick up what's actually happening here. So could not find any detach points. That's an interesting problem. Let's go back to the haulage rule for that one. What have I done wrong? Oh, I've overshot the road. Is that because my dump is... okay, so when I'm actually to the left or the right of this system, so the look east to the road part needs a counterpart, and this is what I'm more used to doing here, is instead of using the conditional groups, I'm used to stacking my vectors and doing reverses, so that you always find the shape regardless of which side of the road you actually start on. So if you start on the left hand side of the road, generally you're looking this way for the road, but there's a handful of records that look the other way. So that should pretty much cover it off. There's a handful of times when it doesn't appear to be working. I think it's because of this weird third point that I created on the actual polyline, so I'm going to scrap it. Yeah, it's getting in the way. We'll leave that early stuff alone. The purposes of the demonstration, that should be sufficient. Yeah. Look east to the road, look west to the road. Yep. And then this point here needs to be referencing the west to the road point, which is the last little bit of it. So, apologies, it's a little bit more chaotic than I'd hoped. Hopefully more, you take this as a template. I'll attempt to do a more structured version of the video once I've made these mistakes now whilst trying to demonstrate it. But that should, besides the first strip or two, be covering off the vast majority, and it's only going to, there's also going to be the same look west to the road requirement over here on the dig side. Let's switch that one around and then change these two to reference that west point. That should have an or on it, just for good description. Look, for those of you who have stuck with it and who have understood what I've done, fantastic. I apologize, it's a little bit wordy and a little bit buggier in getting it set up than I'd anticipated, but the point is that with that effort, so I've been doing this for half an hour, right? A little bit longer than I'd hoped. But within that time, what I've done is for a particular road in a 50-year mine plan, I have done what I'm reasonably confident now that if I flick through this, almost all of, once I get past that initial section, which as I said it's a little bit funny, I am going to have 100% haulage coverage, and I'm saying that now, as I said, with a decent amount of confidence. I'm pretty sure I've picked up all of, there's that early stuff, but now every single record is going to have ramps, switchbacks, an appropriate distance. They don't all look amazing. That's, you know, the purpose of this is not to give you great looking haulage necessarily. The point is to give you, you know, a decent first pass of haulage. And so what you can do is you take this system and it's like, okay, now what I've done is I've done an attach to the mid-pit road. What if I want to do an X-pit road or a floor road? Is you can take this same thing and all you're doing is just toying around with different parameters. This is now essentially, as I said, now that I've worked out the kinks, you've got your left, your right. You can go through this and just edit all of the behaviors. So I'm going to finish off by spending a couple of minutes flipping it around so that you can see the whole point of this is so that if I want to go to the road 2, how quickly I can do that. But that's pretty much it for the learning process. It's more just now I'm going to sit here and flip it around so that the demo model that I give you has got both options. So look up the face, look down the face, remains the same. It's just now the road we're actually seeking is different. We're still looking east or west, it doesn't really matter, so we can pick. All we have to do is change, in this example, we change the polyline that we're looking for. And from this point, we just need to change, we need to kind of just flip the ramps around because the first ramp went left to right, this one's going right to left. So you can actually kind of cheat here and rotate your ramps around a little bit. And it's a little bit painful to rename them because it won't let you do duplicates, but if you're happy to, you can actually just flip them around, and what will happen is it's just that you're only changing which way you go first, so the other one goes left then right. You want to go right then left, so you can pretty much take this and flip it around. So I'm just going to really quickly do that. So as I said, once you understand this system, the power in which it is, you can start turning things around is really quick. So that's it. That is, that's the extent of what needed to be done for the mid-pit to attach road. I'm going to take the dump road on the other side. I'm going to insert copy, go road 2, mid-pit detach, and go through the same process. So the road changes, that one there. And then the ramps, I flip them around. You don't even, I'm renaming them for correctness purposes, but if I'd named the ramps like look east, look west, look east, look west, then you wouldn't even have to do that either. So, but I didn't. So once again, a more polished version of this video will probably be coming in the next few months. It's just finding the time to do these is always a bit of a challenge. You guys are keeping us nice and busy. Can't do that. Let's try that again. Change that to 2, change that to an A so I can rename this one, and we are done. So I run that schedule runs through, haul profiles take 10-20 seconds to generate. Now, bearing in mind, in terms of actual the amount of detail in this particular schedule, how many lines do we have in this schedule? I'm guessing it's somewhere 100,000, maybe about 30,000. So in that 30,000 lines, those 4 rules, I will have now, besides that early section, as I said, which you just extend the road a little bit, I have now got haulage coverage. I'm saying this with reasonable confidence. I'm pretty sure I got that right at the end. Yep. So I've got haulage coverage all the way through that, and that works with polylines. There's some slight adjustments you need to make if your pit is sloping down or sloping up. There's a few things that need to change, but the core of the system remains the same. If your pit angle changes over time, you need to split your rules by date. There's a few other things that we can do to automate that. But, take the template, download it, see how you go. If this is useful for you, let us know. If it's not useful, you need some more information, let us know as well. Support@precisionmining.com. 3539 0000. It's getting a bit late and I haven't had a coffee in a while. Anyway, no one's actually watched this live, so apologies for those of you who come at it later, but I need to make sure I get my Friday videos done. So that's it. Have a great weekend, and yeah, thanks for your attention.